So this morning, we're going to do the area of polar curves. I'm breaking this video up into 2 different videos because it seemed kind of long. We've got 8 examples, so we'll do 4 today and we will do 4 tomorrow. Now, the area of polar curves, given by this equation, area is equal to the integration from alpha to beta of 1/2 r squared d theta. So let's go ahead and look at number 1. You're going to find the area of the region enclosed by r is equal to 3 plus 3 cosine theta. Okay? So find the area of the region enclosed by r is equal to 3 plus 3 cosine theta. Now, you actually know the whole beginning part of this. You know the 1/2, you know the r. The only thing you don't know is what the alpha and the beta are. Okay, so you need to know where you're going to start and where you're going to finish. So the way we do that is we actually graph this thing. So when we're graphing, you're going to make your little table here, and you got your theta. Now we were doing degrees, so we were doing 0, 90, 180, 270, 360. Okay? And when we're going to put it in here, then we're not going to put it as degrees. So if you'd rather think of this as radians, that's fine. Just make sure you know that 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. Okay? So we're going to start with 3 cosine theta. Now, cosine starts with the amplitude, so that's 3, and then it goes to 0, then it goes to the negative amplitude, back to 0, and then back up to the amplitude. Then we go here, 3 plus all of that stuff. So 3 plus 3 is 6, 3 plus 0 is 3, 3 plus a negative 3, that's going to be 0, then we're back to 3 and 6. Let's take a look at what this thing looks like. So if we're going 6 towards the 0, our dot's right here, 3 towards 90, then we're at 0, then we're doing 3 towards 270, and then we get back down to our 6 at 2 pi. Now, the lines, so the dots are in a line, so we know that this is going to be a cardioid, so the cardioid is the one that looks like the heart, okay? And you sketch that graph. All right, so if we want to find the area enclosed by this, you talk and you look about how it is that you went through the process of closing that area. Your first dot was right here. This is where you got started, at 0. 0, you started at 6. You moved all the way up, and then at pi over 2, you were up here at 3. Then at 180, or pi, you were here at 0. Then at 3 pi over 2, you were at 3, and then all the way getting back to 2 pi, you closed the circle. So you went from 0 to 2 pi to get the entire thing. Now, we're going to be putting these in our calculator. We're not going to be doing these by hand today. So you're going to do math 9. You're going from 0 to 2 pi. And now I usually just put 1/2 because 0.5, it's easier than doing a fraction. And then I need to start my parentheses because this has to be squared. Now be careful and watch what I do in my calculator to make sure that you're putting it in correctly. 3 plus 3 cosine. Now notice when I say cosine, it gives me a first parenthesis. So when I say x and close the parenthesis, I haven't closed the parenthesis for r. I just closed the parenthesis for x. So I have to close the parenthesis for r and then put my squared and then put the dx. So make sure that it's the second set of parentheses before you put your squared. You should be getting the answer of 42.412. Okay. Now, you could think of this in terms of symmetry as well. Now, we need to look at it in symmetry because in some cases it's going to be actually easier to do it with symmetry. So look at the top half of this thing. The top half of this cardioid is symmetrical with the bottom half of the cardioid. So we could find just the area of this top half and multiply it by 2. So it's actually the exact same formula, The difference is what your intervals are going to be. From alpha and beta is going to be a little different. So let's look back at our table on our graph to see where we started. Well, we started here at 0, okay? 0 degrees, we were out here at 6. And then we did pi over 2, and then we ended right here at pi. That would get the area of just the top half if you're going from 0 to pi. Now, you multiply that by 2, because this will only give you the area of the top half. Multiplied by 2 would get you the area of the bottom half as well. So let's take a look. If we put 2 in, then we have math 9 from 0 to pi of 0.5 times the parenthesis of 3 plus 3 cosine x. Make sure you close that parenthesis twice, and then you do your dx. And you get the exact same answer of 42.412. Okay? So that is super helpful. Symmetry. We're going to look at some symmetry as we go on down these examples. Number two, find the region in the first quadrant for r is equal to 2 plus sine theta. Now, the region in the first quadrant, okay, we're finding an area for the region in the first quadrant. So because you're in the first quadrant, you know it's going to be from 0 to pi over 2, because that's the region in the first quadrant. So for this one, we don't have to worry about graphing it. Now, if they wanted us to find half of it, or if they wanted us to find a quarter of it, then you would find half or a quarter. And if they wanted to know different things, then you might have to graph it, but not all of them do you have to graph. So for this one, simply it's 0 to pi over 2, because that's the region in the first quadrant, of 0.5 times r squared. So if we put that in our calculator, we have math 9. From 0 to pi over 2, you got 0.5 times 2 plus sine theta. Don't forget to do the parentheses twice before you put in that squared. And then you have your dx, and that equals 5.534. Okay, so that one's a nice, easy one. They basically gave you the alpha and the beta that you would need. All right, let's look at number 3. Not as easy. Number 3 says, find the area of the region enclosed by the rows. R is equal to 5 cosine 2 theta. Okay? Find the area of the region enclosed by the rows. R is equal to 5 cosine 2 theta. Okay, so how do I do this? Well, the first thing I like to do with these is I do like to graph them. So 2 theta is equal to 0. Now the reason I started at 0 is because it was cosine. Now I like to remember that because cosine has a 0 or an O in it, and so O reminds me to start with a 0. Plus, now 2 is an even number, so even number I'm going to do 180k. Okay? So 2 theta equals 0 plus 180k. Divide by 2, I find out that theta is 0 plus 90k. So that means that my first petal is going to start out here at 0. And it's going to be every 90 degrees. And it's going to go out by 5. I don't really need 5 lines if I know that that's just at 5. And then I'm going to come up here and that's going to be 5. And then over here 5. And down here 5. And I have my rows. Or flower, so to speak. Okay? So, because I started this, I started at 0 degrees and I went out 5. So right here was my start. Okay? And I started at 0. So when I'm doing my integration, I'm going to start at 0. Now, I can't do all the way to 2 pi because it's not the entire circle. We're just looking at these little tiny petal pieces. Okay, and I'm not finding all these different things on the inside. So here's the trick. You're going to find the area of this piece right there. And if you find the area of that piece right there, let's count how many half petals there are. So this piece, you've got 1, 2, 3, 4, 5, 6, 7, 8 of them. So if I find the area of that little half petal right there and I multiply it by 8, I will have the area of all of the petals. Okay? So what do we need to know? I need to know, well, if I started at 0, what would be my radian if I got back to 0? So I need to know the very first instance that my r returned back to 0. So how do I do that? Well, I take this, r is equal to 5 cosine 2 theta, and I set that equal to 0. And I want to solve for theta. So divide by 5. Now, you think to yourself, when is cosine equal to 0? Cosine is equal to 0 the very first time at pi over 2. Okay, so that means that 2 theta has to equal pi over 2. Why? Well, because when I'm teaching this in math analysis, I go and I say, okay, forget about that 2 theta and say cosine x is equal to 0. Well, you know that cosine of pi over 2 is equal to 0. So x is equal to pi over 2. But I've replaced x with 2 theta. So that means 2 theta has to equal pi over 2. Because what I'm actually looking for is theta here, not x. So divide both of these things by 2, and I find out that theta is equal to pi over 4. So that's telling me that I'm returning right here to 0 at pi over 4. That's the first time cosine gets back to 0. So I'm doing 8 times the integration from 0 to pi over 4 of 1/2 r squared. 1/2 r squared. So put that in our calculator. We have 8 times, math 9, from 0 to pi over 4 of 1/2 times r squared. So 5 cosine of 2x, make sure you're doing 2 parentheses, dx, you hit enter, and it equals 39.270. Okay. All right, number 4, our last one for today. Number 4. So we are going to find the area enclosed by the rows. R is equal to 3 sine 3 theta. All right, so 3 sine 3 theta. Let's take a look here. So the first thing we want to do is we want to graph it. So 3 theta is equal to 90. I know it's 90 because this is sine. Sine doesn't have an O in it, so it's not going to be 0. We're going to make it 90. Plus 3 is odd, which means we're going to go all the way around the circle 360k. Divide by 3. You have theta is equal to 30 plus 120k. All right, so you're going out 3. Your petal is out 3. And you're going, so like it's going out here. 1, 2, 3. Now notice I don't have my graph, but that's okay. We just kind of want to get an estimate. We know this is at 30 degrees. So this right here is pi over 6. Something really important for us to know. That we start right here at pi over 6. And then we go 120 degrees. So that's going to take us somewhere over here. And then another 120 degrees is going to take us somewhere down here. So we've got our 3 petals. So it's going to look like this. Okay? Now, our first point was at pi over 6. How did I know that? Because they told me I'm starting my pedal at 30 degrees. This last one, I started my pedal at 0. Oops, sorry. Let's get it so you can see it. I started my pedal at 0 because 0 was where the pedal was at its largest point right here. And then I went this way, okay? Because you want to go in a positive direction. You don't want to go in a negative direction because then that'll make these backwards. I'm not saying it's impossible, it just makes it a little more difficult. It's always better to go in a positive direction. So here, we start right here. And we're at pi over 6, and we're going to go in a positive direction. So we're going to go towards that way, and we'll get this half right here. Well, how many halves are there? 1, 2, 3, 4, 5, 6. Because if you break that in half, you're going to have 6 of them. You're going to start at pi over 6. Now, you again want to know what it takes to get back here to 0. So how are we going to figure that out? Or is there another way to do it? Okay, so you could set 3 sine 3 theta equal to 0 and solve, and I'll come back to that. But is there another way to go? Could I instead find the area down there? Wouldn't that be the same? So right here, here you are at 0, and you're going to go up to pi over 6. So you could go from 0 to pi over 6 of 1/2 r squared. Now, if I were doing this one, how would I get back to 0? So I have sine of 3 theta is equal to 0. So I've got my 3 theta is equal to, where is sine equal to 0? Well, it's equal to 0 at 0. Okay, but we were already past 0. We were at pi over 6. So where's the next place that it would equal 0? And that's going to be at pi. So then if I divide both of these by 3, I find out that theta is equal to pi over 3. So I would argue that when I put these both in my calculator, they're going to give me the exact same answer. So let's check. Let's hope they do. If they don't, we'll be sad and we'll have to figure out why and fix it in the next video. So we're going to start with pi over 6, and we'll go up to pi over 3. And we'll do 0.5 times 3 sine 3x quantity squared. Don't forget your double quantity. And you get 7.069. Okay, so we started at pi over 6, and we ended right here at pi over 3. Now remember, I didn't pick 0 because I knew, okay, well, sine is equal to 0, but I'm already at pi over 6, so I need to go to the next one. Well, the next time sine was equal to 0 was at pi, and then I found my theta would be pi over 3. Now let's look at this one. If we do 6 times math 9 from 0 to pi over 6, will we get the same thing? We should. So it is 3 sine 3x, parentheses, squared, dx. You hit enter, and voila, you've gotten the same thing. Now, are there other intervals that you could do? Of course. But the further you get away from 0, the harder it is going to find those intervals of when you were here, and then when you got there, and when you were here, and when you get to the next spot. So especially when we're not making a table, instead we're using this just to find our graph. Now, perhaps in this case, Zrumsky's way is a little bit easier, because in Zrumsky's way, you're picking all sorts of stuff. You're doing 0, and then you're doing pi over 6 and pi over 4, and then you're doing pi over 3, and you're keeping on going. So you'd be able to see the direction that everything's taking. So in that case, you'd actually have an easier time of finding this. I use it by logic and then by finding out where it's equaling to 0 from my graph of what I'm looking at. Okay? All right, so that's going to finish today, because I promised you we would do some shorter things. Tomorrow we're going to do 5, 6, 7, and 8, it is going to change it up a little bit. It's going to do area of two things that are overlapping, and it just gets a little more complicated, and it would take us probably another 20 to 30 minutes, which would make this video way too long. So I will give you more tomorrow. Have a great day.